So we are continuing our series of solving thermodynamics PYQs. Here we have a question on heat engine. Let me read it out. A Carnot engine operates between two reservoirs at temperatures T1 equal to 400 Kelvin and T2 is equal to 300 Kelvin. If the engine receives 2000 joules of heat from the source in each cycle, the work done by the engine per cycle is. So this is a question on Carnot's engine. It's actually part of the JEE Mains syllabus. Many people feel that it's not, but it is. So here we are going to use the idea that efficiency is defined as work done divided by heat absorbed. And in case of Carnot engine, efficiency also happens to be 1 minus T2 divided by T1, where of course T2 and T1 must be in Kelvin. You should substitute these values in the absolute scale. So we are going to use the fact that they have given the total heat received by engine is 2000 joules, the value of T2 is 300 Kelvin and the value of T1 is 400 Kelvin. This will tell us W divided by 2000 joules, that's the heat absorbed, 1 minus 300 divided by 400. So the work done will be equal to 2000 into 1 minus 3 by 4, which is 1 by 4, which is basically 2000 divided by 4, which is a 500 joule. So this happens to be option 2. Dear students, here we have a replica question based on the similar Carnot engine question that we solved before. Kindly attempt this question, pause the video, read the question, attempt it and give your answers in the comments. While referring to the answer of this question, write homework 1. I'll understand that it is the answer to the Carnot engine question. Another very frequent question in JEE Mains is the dissociation of a molecule into atom and its effect on root mean square speed. Let us see this question over here. It says the root mean square speed of oxygen molecules O2 at temperature T is V. If the temperature is doubled and oxygen gas dissociates into atomic oxygen O, the new RMS speed will be. So, what are the changes that are occurring? So, first of all, if temperature T1 is T and V1 is V, they are telling the second temperature, final temperature is 2T and we need to find V2, that is what we need to find. Apart from that, they've also told that initial molecular mass is of O2. Why? Because initially you had oxygen molecules which are always diatomic. So we will take its molecular mass 32 grams. But in second case, capital M is only of O. And you know atomic hydrogen has a gram atomic mass of 16 grams. So recalling that VRMS is root of 3RT by capital M, we can use the proportionality that this is proportional to root T by M. We can do V2 divided by V1 is equal to root of T2 divided by T1 into root of M1 divided by M2. Now this is clearly our M1 and this is clearly our M2. So whenever molecules dissociate into atom, that causes a change in the number of moles and the gram atomic or molecular mass. In this case, in VRMS, we have nothing to do with the number of moles. It is independent of number of moles, but it does depends on the atomic or molecular mass. So now we do the calculation. Root of T2 divided by T1. T2 is 2T and T1 was T. Root of M1 divided by M2. In the first case, your molecular mass is 32 grams and in second case, your gram atomic mass is 16 grams. So basically you get V2 would be equal to root 2 into V, which would be equal to 2V. This would indicate that option 2 is the correct answer. Okay dear students, here we have another replica question based on the previous question that we solved, where a gas molecule dissociates into its atomic form and the temperature is also affected. Please give your answers to this question in the comments under the heading of homework number 2. Okay students, we are taking one last question for this video. This is a tricky question and most of the time students get it wrong, and it repeats a lot. So let's discuss this. 2 moles of monoatomic gas are mixed with 1 mole of diatomic gas. What is the value of gamma, which is the adiabatic exponent for this mixture? Now the common mistake that students do is they take the mole weighted average of the two adiabatic exponents. Like if you have a monatomic gas, you will take its adiabatic exponent as 5 by 3, and you are going to take a diatomic gas adiabatic exponent as 7 by 5, and then you will do 2 into 5 by 3 plus 1 into 7 by 5 divided by 2 plus 1. So why this is wrong? Because this is not derivable from any law. Any fundamental law cannot be used to derive this formula, so it's wrong. If you're not getting it on the basis of any laws of physics, then it's a wrong formula. The correct approach would be to conserve total energy. So when you conserve total energy, we know the internal total energy of a gas is F by 2 nRT, or F by 2 can also be written as 1 by gamma minus 1. So here I am doing in terms of degree of freedom. You can also do in terms of gamma. So if I write total internal energy of mixture should remain conserved, it should be equal to the initial total energy of the individual gases, then we see that the total internal energy of mixture will be F mix by 2 into N1 plus N2 divided by RT, because after mixing we have total number of moles of N1 plus N2. And before mixing we had F1 N1 RT divided by 2 and F2 N2 RT divided by 2. So now you can cancel out the 2's and you can cancel out the RT's for sure. This will give you F mix is equal to M1 F1 plus N2 F2 divided by N1 plus N2. Note that if you use this formula, you will not get the weighted average because the gamma minus 1 is in the denominator. So you can't simply take the weighted average of gamma. Now that you have obtained F mix, you can use gamma mix is equal to 1 plus 2 by F mix. That's the relation between gamma and F. So use the values given in the question. We have 2 moles of monoatomic. Monoatomic gas has degrees of freedom 3. And we have 1 mole of diatomic. Diatomic gas has degrees of freedom 5 divided by 2 plus 1. And you will see that the degrees of freedom of the mixture is 11 by 3. So gamma mix will be 1 plus 2 by F mix. F mix is 11 by 3. We just substitute that and you get the degrees of the gamma of the mixture, adiabatic exponent of the mixture as 1.54, which is approximately option 1. So option 1 is our correct answer. Alternatively, you can also calculate Cp mix and Cv mix and take the ratio to find gamma mix. This can also be derived using conservation of internal energy and first law of thermodynamics. However, this formula that generally students use for gamma mix as N1 gamma 1 plus N2 gamma 2 divided by N1 plus N2 is based on their intuition, which is wrong. It's not based on any physics principle. So don't go by your gut feeling. This is a very, very tricky question. Furthermore, I have put one replica question over here. Pause the screen and attempt this question and write your answers in the comment section under homework 3. Thank you very much for watching this video. Wait for the next video. Thank you.